Okay, this is 6G. It's the last unit in 6. And this is going to be the last unit that's going to be on the test. So it's small stuff, but like they ask this on the IB exam. They'll ask you questions like, is this function even? Is this function odd? So let's talk, what we need to talk about is the type of symmetries. So there's 3 types of symmetry. Though there's many types of symmetry, but the main ones are rotational symmetry. So we have symmetry. Rotational. And simply put, the idea is if I rotate something a certain degrees and it looks like I didn't move it at all. So like the letter X. You know, I wrote, here's the letter X on my paper. Here's X. And then I rotated 180 degrees and it looks like I didn't change it. So it has rotational symmetry of 180 degrees. Or take like an equilateral triangle and rotate it 120 degrees, it looks exactly the same, or it maps onto itself. So that's the idea of rotational symmetry. After a rotation about a point, the image maps onto itself. That's the idea of rotational symmetry. Another type of symmetry is reflection. And that's simply like a parabola and the axis of symmetry. There's some line that when you reflect everything through it, it maps onto itself. So after a reflection through a line, the image maps onto itself. Perfect example, a parabola, like y equals x squared. The axis of symmetry of y equals 0, it's a perfect reflection. Or it's like looking at the mirror, yes. The last type of symmetry is translational symmetry. And the idea is after a shift, right, up, down, left, right, after a shift, the image, maps onto itself. Now, we're not going to get to this right now, but what I want you to do is I want you to go to Desmos, and I want you to do y equals sine of x, and then I want you to do y equals sine of x minus a, and I want you to tell me how much you have to move a so that the second graph shifts onto the first graph, or how often, and we can talk about that in class. Now we're going to do it for sine, or you might want to, you might do sine, or you could change it to, cosine of x minus a, and you'll discover the relationship between sine and cosine. Good. Now I want to talk about these 2 things. Well, for this unit, we're going to talk about rotational and reflection. Now, if a function has rotational symmetry, specifically, if you can take a function and rotate it 180 degrees and it looks exactly the same, we call that function odd. Call it odd, and we say that f of negative x is equal to negative f of x. If, when you replace f of x with negative and you get a reflection over the y-axis and it's symmetric, we say it's an odd function. Your example, y equals x cubed. That's an odd function. The next type of function we're interested in is reflection symmetry. We say it's even. I'm sorry. I apologize. Start over again. Rotational symmetry. if you can take this function, turn it upside down, rotate it 180 degrees, and it maps onto itself, we say the function is odd. Now, from a function point of view, it's, f of negative x. If you replace the x with negative x, you get negative f of x. Reflection is after reflection to the line. So we say it's even if f of negative x equals f of x. And that is what we know. That's y equals x squared. Nice. So you're going to be asked first, is this function even or odd? So what you're going to do in both cases is you're going to replace the x with a negative x and see what happens. So is f of x equals 3x squared plus 1 odd, even, or neither? So you're like, fine. So test f of negative x. Well, that's 3 times negative x squared plus 1, which is equal to 3x squared plus 1, which is equal to f of x. Because f of negative x goes back to my original f of x, the function is even. Next example, g of x, let's see, g of x is equal to x cubed minus x to the 5th. Is that function even or odd? Once again, if you've been looking through the IB exams, you know they ask this. Can you see the board? Is it too dark? It's good. Is it even, odd, or neither? So you're like, fine. Replace x with negative x. We have negative x cubed, minus negative x to the 5th. Well, negative x cubed is negative x cubed, and negative x to the 5th is negative x to the 5th, so it's positive x to the 5th. But I want to pull out a negative, so I get x cubed minus x to the 5th, which equals negative g of x. Because g of negative x equals negative g of x, can you see down there? This is odd. That's basically it. Now, what's great about this, so what's great about this is that it helps you, because if you know something is odd, you know what, I'm going to ask you, hopefully you remember, when we start doing calculus or trigonometry, I want you to say in the future lessons, why does knowing something's odd or even help us? But right now, you need to be able to determine whether functions are odd or even. And the last little thing they ask you to do is, they might say, tell me about the product of 2 odd functions. Tell me about the product of 2 odd functions. So, what is the product of 2 odd functions? So you say, fine, and this is, you can figure this. This is kind of interesting. So we're going to let f of x and g of x be odd, and we're going to let h of x equal to h of f of x times g of x. So I want to know what the product of 2, this is kind of interesting, because you have the question is, you have 2 functions that both have rotational symmetry. Now, what happens when I multiply them together? Is there a new type of symmetry that emerges? And the answer is yes. I want you to test, see, so I want you to prove that the product of 2 odd functions is an even function. Okay, we're back. So, h of x equals f of x times g of x. So, I want to know what happens when I replace the x with negative x. Well, this becomes f of negative x times g of f, negative x. Sorry. So this is basic functions. Well, these are odd functions, which means this is This is negative f of x. And because this is an odd function, this is negative g of x. Well, negative times negative is positive. Even. Nice. Interesting, right? An odd times an odd is an even. Now this means that this has symmetry over the line, the y-axis. And we can see that's true because, for example, like y equals x, which looks like this, and y equals x cubed, which we know looks like this. The product is x to the fourth, which looks like this. Odd, odd, even. I think that's cool. Just a couple of things. Some odd functions. The big odd functions are sine of x and tangent. The even functions are cosine of x. And that's, if you think about it, think about this for a second. Was my battery running low? I'm down to the last 5. Okay, watch. This is kind of cool. That's why, if you have sine of 45, if you have sine of negative 45, that's putting you in the 4th quadrant. So that's like negative sine of 45, right? And then the last thing is cosine is even. Let's think about this. The cosine of negative 50 is equal 50 in this takes us to the 4th quadrant, but cosine is positive in the 4th. So it's equal to negative cosine of... Nice. 6F. And then practicing everything in the back of the unit. And I'm out of battery power.